بسم الله الرحمن الرحيم والصلاة والسلام على أشرف المرسلين سيدنا محمد وعلى آله وصحبه وسلم. السلام عليكم ورحمة الله وبركاته. This is me, Dr. Salsabil Kamal. I'm clinical immunology consultant. Our session will be about cytokine. So the objectives of this session is to define cytokines and to discuss common features of cytokines and illustrate the different action of cytokines. Okay, what is cytokines? Cytokines are small signaling proteins that are secreted by various cells, especially the immune cells, and play a crucial role in regulation of the immune response and inflammation. So cytokines, from its name, it is cyto mean refer to cell and kines mean motion. Okay, so it is a small protein. Their role is to act on cell motion. So it is signaling protein secreted by various cells in the body, but mainly by the immune cells. And this cytokines plays a crucial role in the regulation of the immune response. Okay, cytokines act as messengers between cells and are involved in cell communication, influencing the behavior of other cells by binding to specific receptor on their surface. So it is proteins that act as messengers between the cells, and every cytokines or every protein have a specific receptor on other cells, or it may be on the same cells. So this is cytokine secreted from the cell on the left side, okay, and it acts on receptor in the other cell on the right side. Cytokines act as stimulatory or inhibitory signals between cells, and those between immune cells are called interleukins. You know that the name of white cell is leukocytes, okay, and the cell of the immune cells of the immune system are leukocytes. So when it's secreted from a leukocyte and act on other cell, the leukocyte, we call them interleukins. Okay. So those secreted by macrophage called monokines, and those secreted by lymphocyte called lymphokines, and cytokines that induce chemotaxis. You know chemotaxis. Chemotaxis is mean cell movement according to chemical gradient. So cytokines that induce chemotaxis, we refer them or we call them chemokines. And a good example for chemokine is interleukin 8. So by now we know what is cytokine. We define the cytokine, and now we want to know the common features of cytokine. So cytokines have short half-life and they are rapidly degraded, so it is difficult to measure in the circulation. Have short half-life, it's protein, and a short half-life, and they are rapidly degraded. So when I want to measure the level in the circulation, it is difficult to measure. Okay, and despite that, it can be measured. So most of cytokines act locally within the cell's microenvironment, the microenvironment around the cell, which confine their action to particular site. And some act on the cell of production itself, promoting self-activation and differentiation through cell surface receptor. So cytokines may be secreted from cell and act on the same cell, okay? And some act on distant part of the body. Here, cytokine may be autocrine secreted from the the cell and act on the same cell that secrete the cytokine. And it may be paracrine. Paracrine, it's secreted from the cell and act on nearby cell. And it may be endocrine, secreted by the cell and act on distant site. It circulate in the blood and act on distant site. So many cytokines are pleiotropic in their biological effect. What we mean by pleiotropic effect? Pleiotropic effect that the cytokines may affect multiple organs in the body. So it may act on multiple cells secreted from one cell, but act on multiple cells. This characteristic or this feature, we called it pleiotropism. Also, most cytokines exhibit overlapping function, illustrating the redundancy of the group. So if we see this picture, this is pleiotropism. Pleiotropic means that the cytokines secreted from the cell and act on multiple cells, while redundancy, so different cytokines act on the same cell. Different cytokines here in this picture, like interleukin 2, interleukin 4, and interleukin 5, act on the target cell or on the B cell. All of them act on the B cell. We call this redundancy. So the general feature, pleiotropism or pleiotropic effect and redundancy, and also it acts synergistic effect, mean that some cytokines do the same action بنسميها synergistic. هنا مثلا like interleukin 4 and interleukin 5, they do the same action on the B cell. This is called synergistic effect. So what is the difference between redundancy and synergistic effect? Redundancy means that different cytokines act on the same cell, but their action may be different. While synergistic effect, multiple cytokines act on the same cell, but their effect is or their effects are the same. Also, cytokines have antagonistic effect. Antagonistic effect is the opposite of synergistic. Antagonistic means that different cytokines act on the same cell, but their action is opposite. Their action are opposite. Okay? So, what is the effect of cytokines, or what is the action of cytokines? Cytokines promote non-specific immunity and inflammation. So it promotes innate immunity and inflammation. An example like interleukin 1, interleukin 6, and tumor necrosis factor alpha and interferons. Also, it causes lymphocyte activation, cross, and differentiation. So it affect the specific immunity, and a good example is interleukin 2. Interleukin 2 is cross factor for lymphocyte. Also, it causes colony stimulation from the bone marrow, and example like granulocyte colony stimulating factor. And also there is some cytokines act as regulatory cytokines like interleukin 10 and transforming growth factor beta, and also some cytokines, as we said, act as chemokines like interleukin 8. So interleukin 1, the source of interleukin 1 is or are macrophages, endothelial cells, and some epithelial cells. And the action of interleukin 1, it acts on endothelial cell, cause inflammation and coagulation. Also, it acts on the liver, cause acute phase protein synthesis, and this also occurs via interleukin 6. So interleukin 1 is one of the pro-inflammatory cytokines. It acts on the liver and cause acute synthesis and production of acute phase protein. Acute phase protein like C-reactive protein and other acute phase proteins. Also, it causes inflammation and coagulation in the endothelial cell. Also, it acts on hypothalamus, cause or induce fever, and also it acts on T cells and cause T helper 17 differentiation. There are several types of T helper cell. One of them is T helper 17. Interleukin 1 is the driving force for T helper 17 differentiation. Interleukin 6. The source of interleukin 6 is macrophages, endothelial cells, and T cells. Also, interleukin 6 is pro-inflammatory cytokines. It acts on the liver, cause synthesis and release of acute phase protein, and also it acts on P cell, cause proliferation and differentiation. Tumor necrosis factor alpha. The source of tumor necrosis factor alpha from macrophages and T cells, and it acts on neutrophils, cause activation and promotion of inflammation, and on endothelial cell, cause inflammation and coagulation, in the liver, cause synthesis and production of acute phase protein, and in the hypothalamus, induce fever, and in muscle and fat cause catabolism and cachexia. So in chronic inflammation or in malignancy, there is a secretion of a high level of tumor necrosis factor. So there is loss of muscle and fat, cachexia mean weight loss or loss of the muscle mass, and there is fever because of this tumor necrosis factor alpha. So tumor necrosis factor alpha and interleukin 1 have synergistic effect. They cause fever and they cause muscle proteolysis and cause synthesis and secretion of acute phase protein from the liver and so on. Interleukin 2 secreted mainly from the T cell and mainly T helper 1, and the action of interleukin 2, it acts on T cell, cause growth and differentiation. So interleukin 2, we called it T cell growth factor. Also, it acts on B and NK cell, causing their growth and differentiation. Interleukin 12 secreted from dendritic cell and macrophages, and it acts on NK cell and T cell, stimulate the NK cell and T cell to secrete gamma interferon, which in turn act on macrophages. يعني الماكروفاج يحصل لها stimulation تطلع لنا interleukin 12, and this interleukin 12 act on the NK cell and T cell, and NK cell and T cell secrete gamma interferon, and this gamma interferon act on macrophage. Also, it acts on T cell, cause T helper 1 differentiation. Gamma interferon secreted from the NK cell and the T cell, and it acts on macrophages, cause their activation and augment the action of the macrophages, and it also acts on the B cell, stimulate antibody synthesis. Okay, type 1 interferon alpha and interferon beta. Interferon alpha secreted from the macrophages and dendritic cell and act as antiviral cytokine. It increases expression of MHC class 1 and activate the NK cell. Also, interferon beta secreted from fibroblasts, and it acts or exerts an antiviral action, and also it causes increased MHC1 expression and activate the NK cells. Interleukin 10 is secreted from the macrophages, dendritic cell, and T cell, and it is action on macrophages, dendritic cell. It causes inhibition of interleukin 12 production. So some cytokines are inhibitory cytokines, and one example of these inhibitory cytokines is interleukin 12, interleukin 10. The interleukin 10 inhibit the production of interleukin 12, so it stop the inflammation or stop the immune response or immunological reactions. Transforming growth factor beta also is one of the inhibitory cytokines, and it is secreted from many cell types, and it acts as inhibitor of inflammation, and also it acts on T cell cause differentiation of T helper 17 and regulatory T cell. Also regulatory T cell is the cells that regulate the immune response. It can stop immune response or immune reactions. This is the table with cytokines and their actions. Interferon family اللي هي interferon alpha and beta act as antiviral proteins, and chemokine family اللي هو interleukin 8 like interleukin 8. This directs cell migration, adhesion and activation. And tumor necrosis factor alpha tumor necrosis factor family regulate the inflammatory and immune response. It induces the immune response, it induces the inflammation. And interleukin family have variety of actions depending upon type of interleukin. And hemobiotin, like granulocyte colony stimulating factor, it promotes cell proliferation and differentiation. And also transforming growth factor beta family, this is the inhibitory cytokine. It regulates the immune response. So thank you for your listening.